We are going to take a look at the epicenter activity from the lesson 2.13. It doesn't show up, it doesn't completely work in my browser, so I know that it might not work in yours, but I'm going to walk you through what the activity looks like. So if it comes up blank for this point, San Diego, don't worry, we'll go through the rest together. Let's start by looking at Boise, Idaho. If we move this slider, this is going to show us data that's collected from seismic stations over time. You can see that this one section becomes highlighted, and what we are highlighting is the arrival time of P waves at the seismic station that's located in Boise. And we time how long from when the primary wave first arrives until the secondary wave arrives at the same station. We calculate that time and subtract the difference. And we can see here on our graph, primary wave arrival time minus secondary wave arrival time in minutes is about 1.5 minutes. And if we follow that line over on this chart to this sort of pre-calculated line and then go down, it tells us that the intersection point, or the distance that the earthquake must be from Boise, is about 900 kilometers. And so we can draw a circle 900 kilometers away from Boise and know that the earthquake must have occurred somewhere along that circle. We can do the same thing for Denver. We can slide this bar out until we see the primary and secondary waves have both arrived, and at that time interval we move along our chart and we see that it must be somewhere around 1,600 kilometers from Denver. And then to find out the epicenter, so we have those three circles, if we could get San Diego to show up, and here on the chart I'm going to start from the time that the earthquake begins. So we don't know where it is happening, but there's an earthquake occurring somewhere on this map. I'm going to slide the timer so that we can see the arrival of P and S waves to each of these three seismic stations. And we see that right around 60 seconds, the P and the S waves have both arrived in San Diego. So we have a circle now that tells us about how far, or tells us exactly how far from San Diego the earthquake occurred. So somewhere along this green circle is the epicenter of the earthquake. When we keep going, it takes a little bit more time because Boise is further away. We now see that we have a circle for Boise where the P and the S waves have both arrived at that seismic station, and it intersects with the San Diego circle in two different places. So the location of our earthquake must be either here or here. We can't figure out which of those 2 points it is until we see when both waves have arrived at this third station in Denver. So I'll slide the timer across, and when both waves have arrived here in Denver, we see it takes about 2.5 minutes, and that gets us to about 1,600 kilometers, and the points intersect all at one location. So the epicenter of our earthquake must be here at the point, and this is called triangulation. We have used 3 different points to verify the location of this earthquake's epicenter. You could use 4, 5, 6, you could use many more points, but they would all have circles that intersect at the same location. 3 is just the minimum number that you need to identify an earthquake's epicenter.